Socially aware robots using new technique avoid crashing into people. Robots are common now in industries, especially manufacturing. Without these machines, we won't see many items in convenience stores and supermarkets. Adding them into commercial and office spaces is interesting too, except we need to deal with the challenges first. Collision is one main problem, and a new study offers a fresh strategy to overcome it. According to nonprofit charitable organization ProCon, AI doesn't get stressed, tired, or sick, three major causes of human accidents in the workplace. AI can do tasks that will normally endanger a person, which is why lots of construction companies are deploying robots and drones. That said, deploying more of these will endanger human employment. So, there's a delicate balance to maintain if we want to avoid ballooning unemployment rates. Let's say we can keep that balance. How do we stop robots from colliding with people, themselves, or other things in workplaces? Researchers at the University of Toronto have a new strategy for that. Their ongoing project is supported by Apple Machine Learning, and its results will be presented at the International Conference on Robotics and Automation at the end of this month. The data from a simulation has been uploaded on ARXIV for peer review. The team highlighted the key features of their strategy. The first is the use of spatio-temporal occupancy grid maps, or SOGM. These are 3D grip maps in the robot's processor to predict activity at a specific space in a particular period. Using existing trajectory planning algorithms, the robot can choose its future actions. Of course, LiDAR, or light detection and ranging, is included too. Researchers integrated it into SOGM so the network could recognize 4 LiDAR point categories: the ground, permanent fixtures, movable yet motionless objects, and dynamic obstacles. People weren't a part of this aspect. To handle people, they used the machine learning technique called self-supervised learning. Compared to reinforced learning, self-supervised learning doesn't apply the trial and error approach and is easier to comprehend. Being point-centric, the network has a closer interpretation of the raw sensor data. If the team used the other technique, it would mean letting the robot learn the correct thing via crashing into people multiple times, which is ill-advised. Our model is point-centric. Our algorithm does not quantify people as individual objects, but recognizes areas where people should be, said first author Hugues Thomas. The simulation mentioned in the paper was a success, so they're now checking whether they can scale up their network to learn more subtle cues from very dynamic scenes. If robots are to navigate where we do, they have to react fast and correctly. Have you encountered a robot in your workplace or in establishments? Will you be comfortable with a robot roaming around your workplace? Share your thoughts in the comment section. Till our next video, thanks for watching.